Hello everyone, my name is Rolf van Leeuwen, better known as Luivatra, and currently I'm working as a ErgoScript dev at ErgoPad. In this presentation I will explain the staking setup we are working on at ErgoPad and how ErgoScript allows for creating complex and secure systems. End users are keen on having both functionality and security. Usually functionality first, security only when things go wrong. In Ergo, this is achieved using the smart contract language ErgoScript. There seems to be quite a few misunderstandings of how EUTXO works, which is understandable as a lot of people will have experience with account-based chains such as Ethereum, or simply do not have an understanding of the underlying tech. This is fair enough because Ergo aims to be a blockchain for everyone, not just the rich or the tech-savvy. However, due to the peer-to-peer nature of a blockchain, ensuring its security lies at least partly in the hands of the end user. So a certain level of understanding is needed so everyone can be a part of making a secure and fair ecosystem. So I will start this presentation simple and work my way up in complexity, going from briefly explaining EUTXO and ErgoScript to showing what we are doing with ErgoScript at ErgoPad to make robust solutions. So let's start a bit more simple than this. This, I'm sure, is a situation many of you are familiar with. A user called Alice makes a transaction to send 2 ERG to another user called Bob. In your wallet, your assets are presented nicely to you, but behind the scenes, they can be scattered over many UTXOs, which stands for unspent transaction outputs, or commonly called boxes. These are the remains of any transaction that has deposited assets into your wallet. A box cannot be spent partially. So when you use a box in a transaction, all of its contents are spent. Of course, that does not mean that Bob gets all the contents. Any leftover assets get combined into a new box and sent back to Alice's wallet. So here you can see the unspent boxes that are going to be spent in this transaction to send 2 ERG to Bob's wallet. The smart contract language used in Ergo is called ErgoScript. This script compiles into something called an ErgoTree. The ErgoTree is a function that results in either true or false. If it returns false, the transaction will not be accepted. Every single box has an ErgoTree associated with it. Also those that are in your wallet. There's a one-to-one relation between the ErgoTree and the address of a box. A correct ErgoTree will ensure a box is only spent in transactions that are intended and do not allow for unintended transactions to occur, either by accident or by some malicious actor. So ErgoTree is the key to making Ergo secure. The address you have in your wallet is linked to a special kind of ErgoTree, which is very simple. All it does is ensure that transactions that span these boxes are signed by the wallet's private keys. So these boxes that belong in Alice's wallet can only be spent in transactions that are signed by Alice's private keys. So no one else can spend them unless they have access to the private keys, which is why keeping your seed phrase secret is so important. After the transaction is finished, we have a new set of unspent boxes, each with their associated ErgoTrees to make sure they can only be spent in the correct transactions. So the box that lands in Bob's wallet has an ErgoTree, making sure that the box can only be spent in a transaction with Bob's private keys. And the change box for Alice can only be spent by Alice's private keys. So that is a simple use case, but how do we make our own ErgoTree and make sure that we get the functionality we want other than simple transactions between users? And we, of course, also want to make sure that the security of the funds is ensured. To look at an example, we can look at the vesting contract we have made at ErgoPad. The idea behind the contract is that the user gets a chance to buy into a project at a discounted price. The project gains early funding, but wants to prevent the early buyers from dumping onto the market as soon as the token goes live on, for example, ErgoDex. So the tokens are released to the user at a certain frequency, for example, once a month, to smooth out the impact on the market. How do we do that in ErgoScript? So we are looking to make a transaction that looks like this one, where we have the funds stored in a vesting smart contract. And we want to make sure that they are released to the user at a certain frequency, and any remaining tokens need to be stored or need to be kept in the vesting contract. We can't leave them in the box here in the middle because we need to spend the whole box in a transaction. So if we want to, say, keep part of the funds in this box, we need to recreate it with the remaining funds. So how do we do that? Where do we start? Personally, I like to start with the most secure script possible, one that always returns false. So we just add an ErgoTree to this box saying no to any transaction that tries to spend it. It's very secure. These funds are not going to get stolen out of this box. But of course, it's also not very useful because the user will not be able to get them either. So we need to add on to this. So we can start out with, for example, ensuring that this box can only be spent in a transaction that has the user's wallet as an output and the vesting contract itself as the output. In a box, there is registers besides the assets in the box where we can store some data. So in this register, in this case register 4, we can store the user wallet's address to make sure that when this box is spent, the output goes to the correct user. And it can also check that the other output is guarded by the same ErgoTree as this box. So that might look fairly nice and simple, but it opens up for a problem because all we are checking is that these two outputs are here. We are not ensuring that there isn't a third hidden box that might steal some of the funds. So let's make sure that all the tokens, all the funds that are in this box actually end up in these two boxes. We can do that by counting or summing up the funds that go into these two boxes and ensuring that they are equal to what we have in our own box. Is that good enough? No, it's not yet, because the register is not being checked. So this new box, even though it might have the same ErgoTree, might not have the same value in the register. So it could be that even though this box ensures that it is spent to the correct user's wallet, this box might have been tampered with and it might be pointing at a different user's wallet. And on top of that, we are also not checking that the user actually gets the correct amount. It could be that the user is getting more or less than the vesting schedule allows. So we need to add some more conditions. As you can see, the script quickly becomes very large, even for a simple case like this. And every single time you add on to it, you need to ensure that you're not opening up for an unintended scenario where either something just simply can go wrong by accident or a third party can exploit the situation. So it is really important to take your time on this. Do it step by step. Test often in the playground, for example, and invite others in the process of creating this. So you have an extra set of eyes on it, and review it. A little side note about smart contracts on the UTXO, which is also often misunderstood because it's different than what we have on Ethereum, is that they are only evaluated when submitting a transaction. Off-chain code is needed to actually submit the transaction, build and submit the transaction, and only then the on-chain code will be executed. So off-chain code is much more important here than it is in other types of blockchains. So that was a simple example. Let's have a look at staking, which is quite a bit more complicated. In ErgoPad staking setup, a fixed amount of ErgoPad tokens is released every day to be divided between all staking boxes. Emission is fixed and distribution is fair, so APY will be the same for everyone, but will go up and down, all depending on how many ErgoPad tokens are staked in total. ErgoScript does not have any information outside of the current transaction. So to be able to know how many stakers there are and how many ErgoPad tokens they are staking, we need to have a box that contains this information. We solve this by having a stake state box that is part of every single transaction in this system so that it can keep track of every important bit of data that we need to correctly calculate everything. In the beginning, we also have a single transaction that initiates the stake state, the stake pool, which holds all the tokens that are to be distributed over the whole staking period, and the emission box, which will hold the tokens that need to be distributed during the day. So let's have a look at the different types of transactions that we need to build an ErgoScript for. The first transaction we look at is the stake transaction. In this transaction, the user creates a stake box. It does this by using the stake state box as an input as well, because this one distributes a special kind of token to the stake box to give a proof that it was created in the correct way. This way we ensure that only stake boxes that are created with the stake state involved are identified as real stake boxes. And because the stake state is involved, we can ensure that the values in the state are up to date and always updated. In the same transaction, we mint an NFT that is sent back to the user, which is used as the key to be able to unstake the funds later on. In the emit transaction, we start a new cycle. So this will be run once a day. Any leftover ErgoPad from the previous cycle's emission box is returned to the stake pool. and a new emission box is filled with the daily emission. The emission box also takes a snapshot of what information we have in the stake state. This way we can do our calculations for distributing the staking rewards on a stable foundation. Because while we are distributing funds from this emission box to the stake boxes, there might be new stakers that come into the system. So this stake state changes. It's interesting to note that this transaction can be executed by everyone. There is no box here that is dependent on a certain set of private keys. But of course, it costs a little bit of ERG to execute this transaction. So only people that are incentivized by this transaction will want to execute it. But of course, ErgoPad will make sure that this transaction happens every day. The compound transaction is where it gets interesting for the user, because this is where we distribute funds from the emission box into the stake boxes. This transaction will have a stake state and emission box as the first two inputs, but can have an arbitrary, up to a certain limit that the blockchain has, amount of stake boxes. So we can optimize and batch the stake boxes into fewer transactions, so we don't need to execute hundreds of transactions. Of course, that makes the logic a little bit more complicated, because we need to make sure that the values in the emission box and the stake state box are correct, no matter how many stake boxes we have in this transaction. Each stake box will want to ensure that it gets the correct reward and doesn't get cheated. An important bit here for the stake state is to ensure that there's no fake stake boxes here trying to steal some of the ErgoPad tokens. Finally, we look at the unstaking transactions. We have two options here where the user either unstakes everything, so it takes all the ErgoPad, so the initial stake and any rewards that have been compounded on top of it, and wants to put that back into their wallet. In the ErgoPad staking setup, there is a penalty for unstaking early, which means within a couple of weeks from the initial staking. This is to prevent users from buying a lot of ErgoPad tokens right before we launch a new project, just to dump them again right after. If the user decides to unstake early anyways, the penalty will be, instead of sent back into the system, it will be burned. In a full unstake, the stake key will always be burned. The partial unstake is very similar, of course, but the user will want to keep their stake key, and we will want to create a stake box with the remaining funds. The time that the stake or the initial staking time will not change when this happens. So the timer for early unstaking doesn't get reset. So if the user really needs some funds but will get a penalty, then they can unstake exactly that which they need, and then keep the rest to make sure that they won't get a penalty on that. So that was actually the staking setup. I won't go too much into the ErgoScript that we have made for it, which is at the time working in the Ergo Playground, which is a simulation of the Ergo blockchain, and we are working on getting it running into the testnet. But it's possible to see what we are working on because everything in ErgoPad is open source in our GitHub. So if you're interested in the scripts behind it, you should be able to find this in our GitHub. So now we're nearing the end of this presentation. So what are the key takeaways? The important points to remember are that all assets in the EUTXO chain are stored in UTXOs or unspent boxes. Every box is guarded by an ErgoTree, which is a compiled ErgoScript. A transaction can only be executed if every ErgoTree guarding its input boxes are satisfied and return true. Different transactions can have different combinations of input boxes with different ErgoTrees, allowing for complex systems to be built. Complexity always comes at a cost, be it execution cost or security cost, in the sense that it can be more difficult to review and ensure correctness. So simple solutions should always be preferred when possible. That's all for me for now. Thank you very much for listening.